Okay, today we are going to talk about units of measure. So we're going to determine units of measure that are appropriate when solving problems. We're going to identify independent and dependent variables, and we're going to draw and label reasonable graphs. So here we have determine the units of measure that are appropriate for each situation. The first one we have is how fast can a cheetah run? And this one was pretty easy for kids to identify. It's miles per hour. And we just put mph when we wrote it on there. If you want to spell it out, that's fine. And then on B it says determining your electric bill, and this one was a little bit harder. I kind of started giving some hints, but we eventually came up with kilowatts per hour. Okay, the independent variable, this is the variable with a value that is subject to choice. And this is what we had to fill in our notes, subject to choice. In linear equations, x is typically the independent variable. We also started talking about, and in the future we're going to talk about that this is the value that we put into a function, so we call it the input. So it's the x, it's the input, and it's the one that's subject to choice. Okay, your dependent variable is the variable with a value that depends on the value of the independent variable. So it doesn't stand alone, it needs the independent variable. In linear equations, it's typically the y, and if we're talking about functions, if the independent variable is the input, the dependent variable then becomes the output. It's what we get out of the function. Okay, so here on example 2 it says determine the independent value and the dependent value, then sketch a possible graph. So it says the distance a person runs increases with time. So what we did is we circled our two values, our distance and our time, and we said which one probably depends on the other, and we said our distance probably depends on the amount of time that we run. So that means the distance becomes the dependent variable and the time becomes the independent variable. Then to sketch a graph, we labeled the independent variable as the horizontal axis. So we said this is time here, and this one is the distance. And we said if you're going to start running, usually start at 0, and then you go and then you maintain a speed for a while, and then you drop back off until you stop. Okay, our second example says as the dimensions of a square decrease, so does the area. So here the two values that we're going to look at are the dimensions of the square, so I'm just going to circle the dimensions, and then the area. And we said that the dimensions will actually determine what the area is. So the dimensions become the independent variable, and the area is the dependent variable. It depends on the dimensions. So again, you'll label the horizontal axis as the independent, so our dimensions. And the vertical axis as the dependent variable, we'll call it the area. And then we said if you had a square that's 1 by 1, the area is 1. So if we were to graph it, we'd go over 1, up 1, we'd get a point somewhere, something like that. 2 by 2 will give us a 4, so we would go over 2, up 4. And then a 3 by 3 would give us 9, so over 3, up 9, and we can see that we get a graph that is something like this, and we then talked about is it linear, is it not linear, and we came up with the conclusion that it is not linear. And we'll be talking a lot this year about linear and exponential. This is not exponential, but it's definitely not linear. Okay, on example 3, it talks about drawing and labeling a reasonable graph for each situation, and then also identify the independent and dependent variables. We're going to do that hopefully a bunch of times to help you understand that, which one is which. Okay, so it says the temperature decreases as the sun sets. So we have a sun setting I like to say instead of the sun setting, we're going to talk about it as time. And we also have a temperature, and we see that the temperature is going to decrease as the sun goes down, or as it gets later into the night and early into the early morning. So our time here, our sunset, or I should say the temperature, is going to depend on what time of the day it is. So we say that the sun sets, or the time, is what is the independent variable, and the temperature then is the dependent variable. So we label our horizontal axis with the independent variable and its time, and our vertical axis with the dependent variable, and we'll put temperature. I'm going to put TEMP to abbreviate it. And then we said time is obviously starting towards night because the sun is setting, so you could say maybe 8 o'clock is where we would begin, and as it gets later into the evening it is going to decrease, and then eventually it'll level off before the sun rises and it starts to increase. On B, I kind of put this on here for fun, just to tell you what life used to be like. But it says, the more texts I send, the higher my phone bill. It used to be that you had phone bills that were based on the amount of text that you sent, and if you went over a specific limit, then you would get dinged pretty high, that your phone bill would increase significantly. And now they have so many unlimited plans that this really isn't a problem anymore. But so our two things that we're talking about are texts and phone bills. So the more texts I send, the higher my phone bill. So it seems that your phone bill is going to depend on how many texts you send. So that makes the phone bill the dependent variable and the texts the independent variable. So I'll put the texts across the bottom, and I'll put bill for the vertical axis, and it just says the more text you send. You probably have an initial amount that you have to pay, so I'm going to start a little higher instead of at the origin here. We'll start higher, and the number of texts or your phone bill will increase as your texts increase. Hopefully it's linear and not exponential. Okay, an example 4, it says, the table below shows the population of the state of Kentucky over the last several decades. Draw and label the axes on the graph. So we have a year starting in 1960, and we have population in millions. So we're going to take note that the year is probably, the population probably depends on the year, so our population is the dependent variable while the year is the independent variable. So that means when I draw my graph, I'm going to say year across the bottom, and then population, I'll put pop for our vertical axis. And when I go to label this, I need to show that I am not going, because you know this is known as the origin, 0, 0. I'm not going to start at 0 and go all the way to 1960 without showing that there is a gap. So that little symbol will show that there is a gap between those values. So then I can say I'm going to start at 1960. I'm going to leave off the 19. And then I'm going to skip one because my graph's pretty small. So the next tally here, or the next line there, would represent 1970. So I go to 1980 next, 1990, and then 2000. And to represent 2000, we put 0, 0. Then we would be at 210, and then at 2010, and then at 2020. So for our population, it starts at 3. So again, I'm going to show a gap there. And my first one will be 3.0. And since it's increasing, not really quickly, I'm not going to go by ones. I'm actually going to go by tenths. So the next one would represent 3.1. Then I'm going to go to 3.2, and I'm going to skip every other one. 3.3. Nope, I'm not going to make it. I'm going to change my mind. I'm going to go by 2 tenths. So the first little one that I don't have on there, well, I'll start at 3, and this one, the next one would be at 3.2. The next one at 3.4, 3.6. I'll skip, and then up to 3.8. And the next one would be 4.0, so our last one at the top will be 4.2. So from here, I'm going to go ahead and graph each value. Let's change colors so you can see it a little bit better. We go over 60 up 3.0, over 70 up 3.2, and so far it looks like it's pretty linear. We go over to 80 and we go up 3.7. We go again over 90 up 3.7 and we've lost that linear relationship. It's no longer straight. And we graph our last one, 2000 up 4.0, and we see that it definitely has a positive correlation. We can see that as we increase in years, the population also increases. Then we talked about, hey, well, what do you think the projected population might be for the year 2013, the year that we're in right now? And then we also talked about how we measure population and how there's censuses that are taken every 10 years. And we talked about the last census. Anyways, there's lots of other information you can gain from that graph, but what I really want you to be able to do is identify the axes and label them by your independent and dependent variable, and then to graph the ordered pairs. So your assignment will be the 1 unit of measures worksheet. Good luck.